Hello and welcome to Let's Learn SCADA with Smriti. Now you're watching my video, What is SCADA Part 2. I hope you watched my earlier video, that is Part 1, What is SCADA, and in that video I described what is SCADA and what is RTU, what is HMI. I hope you means you saw that video. If you didn't saw that video, I'll put the link in my description. Please go through that video also. And now we'll start what is SCADA Part 2. We will go through the topics like PLC, transducer and MFM. Please subscribe my channel, like this video and give me more support so I will increase the knowledge level of my videos more. So I will put some in-depth videos of on different type of manufacturers also. Thank you. Let's start. As I told you, we will cover all this topic. So in my earlier video, I already covered RTU and HMI. Today I will cover PLC, MFM and transducer. So let's start. So we will start with PLC. What is PLC? PLC is programmable logic controller. So what is programmable logic controller? A programmable logic controller is an electronic device that takes input from plant or machines via sensors, transmitters, executes the logic program using different logical gates in its memory and generates the usual output on actuators to control the plant machines. So it will take input from different switches or devices or transmitters or sensors, and it will put everything in a logical gate, and then it will show you a result. Okay, I will show you example. If I have a switch here, okay, if my switch is 0, it will give, it will switch is off, it will give 0. If my switch is on, it will give 1. So on that case, I can take this signal to my SCADA or my PLC to check if the if I am going to execute the next operation, if my switch is on or off. So generally these signals came in the form of 0 or 1, because computer can only understand booleans. So this type of boolean expressions, different type of boolean expressions, when you are adding two boolean expressions or you are to means making a AND of two boolean expressions are called gates. So we'll go one by one gate. First gate is AND gate. AND gate is a gate like if both the case are satisfied, then only it will give a true signal to the next operation. I can say next operation. I don't know, it will maybe an end result, but it may be a next operation also. So for example, I have a signal from A, signal from B. Okay, if both the signals are true, then only it will give a signal like it's true. For example, I have a uh, breaker called A and breaker called B, two breakers. If my both breaker are closed, then only I can operate my next third breaker. Then it will take a close signal of breaker A and close signal of breaker B, and it will give output to, it will put in an AND gate and it will give a common signal. Yes, breaker A and B is closed. Now you go for your next operation. So that is AND gate. OR gate, similar example, OR gate. If I have two breakers A and B, if any of the breaker is closed, then also I can do my next operation. Okay, any of the breaker is closed. On that case, 0 0 it is 0, otherwise 0 1 is okay, 1 0 is okay. Either two breakers also closed, that is also fine for me. That is called OR gate. So one more gate is there, is called NOT gate. These are like common gates. A lot of gates are there, but I am talking about very common gates you will find out in a logic in PLC. So similarly, another gate is there, that is called NOT gate. So whatever signal you want to invert that signal. For example, one signal is coming, breaker is on, but you need breaker is off. So put a NOT gate, it will on become off. Simple thing. So if you are getting a signal high, but you need a signal of low, but you don't have that, then put a NOT gate. If signal is high, then it is 0. If the signal is low, then it is 1. It will give you the opposite of that signal. Similarly, you have a NAND gate. If you have a AND gate, after that you want to put a NOT gate, then it's fine. Otherwise, you combine NOT gate and AND gate, that is called NAND gate. Similar, have a NOR gate. You have a OR gate, Again you will put a NOT gate. Better to put a NOR gate. It will combine NOT and OR together. It will give a output NOR. So we have enough example here. Now we'll do one thing. We'll have a small exercise in my video. So just discuss about that video. This. So I have an example, like I have a double circuit bus bar scheme. This is very generous. I don't know it is correct or not, but I put very simple. This is example. Like I have two isolators, 89A and 89B, and I have a breaker called 52CB, and I have an isolator 89L, and I have a switch 89LE. So I need to close the breaker of 52CB. So for closing this breaker, I need 89A should be closed or 89B should be closed. Any of the either of the breaker should isolator should close. 89L should be closed, but 89LE should be open because our switch should be open. Then only I should go and give a command to breaker. Very simple. Okay, I don't need also PLC because I have a numerical relay. Then also I can do this, but uh, showing you example, I am using this scheme here. It's very simple scheme, anybody can understand. So you cannot close both the breaker, like 89A and 89B, both you cannot close. Okay, these are showing these isolator and breakers. Now I have a AND gate here, like 89B should be open, 89A should be closed, 89L should be closed, 89A should be closed, 89B should be open, 89L should be. Okay, I'll take a laser point out here, so it will be very easy. 89A should be closed, 89B should be open, 89L should be closed. In this case, it will give a signal called true. Otherwise, maybe 89B closed, 89L closed, 89A open. If either of the signal is okay, then you can close the breaker. But we didn't check the earth switch here, right? We should check the status of earth switch also. So earth switch should be open always, 89LE. So whatever signal will come from this one and 89 earth switch signal I've taken here, then I put it in an AND gate. When this all these conditions will satisfy, it will give a true. So when I will get a true from indication from here, then I will go and the close interlock will be activated. So I can close the breaker. For opening a breaker, we no need to check anything, but for closing a breaker, you have to check everything, all these things. Then only you can close. Otherwise, it will be a accident. So all these things should be there. So generally, these things, this type of schemes you will find out in a numerical relay also. But showing you an example, I've taken this one. So what are the 5 most popular PLC programming languages are there? Okay, so there are actually ladder diagram, that is very much famous. I know about this, how to do, and function block diagram. This is also very simple thing. That also very achievable. And if you are using ABB PLC programming, so FBD is very much famous there, and sequential functional chart and structural text and instruction list. This type of 5 type of PLC languages are there, but most common and famous as per my knowledge is ladder diagram and functional block diagram. So in another chapter we will talk, when I will talk about multi-pro software, because I know the multi-pro software of ABB. So when we'll talk about that software, then we will discuss upon this FBD diagram and ladder diagram. So for programming this language, this is the IEC standard 61131-3 is the IEC standard for a PLC programming. That's it, guys. PLC, it's very simple, and it can be you can be expert in PLC very easily. And I'll give you a small talk also for 50 to 20-minute video next time on this topic. Our another chapter is transducers. So let's talk about transducers. So let's start. What is a transducer? Transducer is a device that converts energy from one form to another. Usually a transducer converts a signal in one form of energy to signal in another. For example, if you have a signal of a current that is in 0 to 5 ampere anything, maybe 0 to 1 ampere secondary anything, and you have voltage like 0 to 110 volt, you directly cannot give those means voltage and current to your ammeter and voltmeter or a wattmeter directly to measure those things. So you have to fractionize those signals to very small means like signals like 0 to 5 volt, 0 to 10 volt, 0 to 4 to 20 milliamps, 0 to 10 milliamps, like to you to change that signal to another form. So in that form only you can measure the current, voltage and wattage, whatever you want, you can measure that. For example, I have a here current transducer example. I just taken a some picture and a graphical representation. If you'll see in the field, you will get R phase, Y phase and B phase. This is my CT. So it is my primary side CT, and this is secondary side CT. So secondary side CT is connected to my transducer. So it will be maybe 0 to 1 ampere or 0 to 5 ampere depending upon my CT. So this the primary, and the auxiliary supply. Auxiliary supply is a very optional. Sometimes you need to give a auxiliary supply to some transducer manufacturers, but I saw a lot of transducer manufacturers, they're self-powered, so no need to give any auxiliary supply also. So you have to take R, Y, B, three type of signals here, and then another side you will get output like 4 to 20 milliamps. I have taken example 4 to 20 is not means exactly 4 to 20 always. Sometimes it's 4 to 20, sometimes it's 0 to 10, sometimes it's 0 to 20, 0 to 40 like milliamps in current, sometimes in voltage also like millivolt, or you'll find in 0 to 10 volt also, 0 to 10 millivolts. So a lot of type of transducers are there. So I've shown you example here. So you're seeing a spare point here. This spare point always be there to connect maybe for RTU, or if you have an analog meter or you have anything else, you can put this to alarm also sometime. So you can use this one. So maybe you will find I'll show you. You will find some more points here. Here in this part you will find some more points maybe for, you can say, the faulty of the NONC points, that is normally open normally closed points for faulty signal of that transducers sometime. And similarly you have a voltage transducer, then you have a PT here, and you have to RYB is connected, and auxiliary supplies are always optional, maximum transducers. So similarly voltmeter also connected. This is the scheme you will find out in any of the substation about transducers. So now let's come to multifunctioning meter. Multifunctioning meter, some people call this one multifunctioning transducer. So we already covered transducer. This is multifunctioning transducer, means this one device can do all the purpose what you have to do. You have to perform with multiple transducers there. Means you for measuring current you are using one transducer, for measuring voltage you are using another transducer, for measuring megawatt or wattage or energy you have to use multiple transducers, right? So this type of multiple transducers can be combined in a one transducer. It's called multifunctioning transducer. So let's start multifunctioning transducer. Multifunctioning energy meter monitors and measures all the electrical parameters such as voltage, active power, apparent power, current, power factor, reactive power, active energy, phase angle, and so on. Lot of things you can measure by using this one. So this is a general example I have taken. It is just a graphical representation, so don't go bit by bit of this picture, but it's almost same. You have a auxiliary supply here. You have R, Y and B for CT, and for PT R, Y, B. This much of signal only required maximum input to a multifunctioning meter. And this RJ45 pin, this is a graphical representation. Maybe you will not get this type of RJ45. Sometimes you will get RJ11 and or 9 pin for as a console port to program those multifunctioning meters, because you need to program sometime the multifunctioning meters, because multifunctioning meters are communicates generally on Modbus, but in different protocols maybe you will find out in the market, but generally you will get 99% case it is Modbus. So Modbus, you have to configure the device with a slave ID and with with some register addresses. You have to configure the device always as per your requirement. For example, you have 30 devices. How does your RTO will understand that which device is what? So you have to address those devices also, like slave address. First device is from my incomer, so my first device is one. Like this, 2, 3, 4, 5. You can put around 30 devices. Means lot of, I think more than 30. As per my knowledge, around 40 devices in a chain, and you can communicate. And those devices will be communicated with RTU, that's called multi-drop method. I will show in my next video, next part, that how it works. And now I can show you how it looks like graphical representation. There will be auxiliary supply for this for this MFMs, and CTPT is always connected, and there will be a port for Modbus port, like it is a positive, negative, and ground. Ground always generally we don't use, but if you have a shielding cable, you should use this ground also. But if you don't have a shielding cable, it's not required. Okay, this ground is not your actual electrical ground. Never put this ground signal to your electrical ground. It will be a bizarrest thing in your life. If you'll put in that in your earthing. Don't put in the earthing. Just that signal is the shielding of the cable. You will find a like a net, like some metal net type thing upper, means it's covering to your cable, that communication cable, that you have to put in this ground. Okay, so let's see how it communicates. So multi-drop, when multiple device connected in a single communication bus or circuit is called is called like multi-drop. Okay, like it RS485 type communication supports multi-drop type. Okay, so what is multi-drop? I have shown you an example here. I have four multifunctioning meters. One, two, three, four. For example, I have four breakers, so four multifunctioning meters. So this is my RTU now in the end. So now I have to communicate from first MFM to all my 4 MFM to my RTU. So I have to give a slave address to each of the MFM first. So I have to configure through that RJ45 pin, or if I have a serial pin, sometime you have to do by the buttons. You will get 2-3 buttons upon those MFMs. You have to push those buttons, and you can configure those MFMs. Also possible, like lot of options are there. Sometimes you will get an optical type connection. If that is a secure energy meter, big size secure energy meter, on that time you will get some optical connection communication cables also. Like this, there is a lot of options are there. So you have to program to first you have to program those multifunctioning meters, like slave address. No slave address should be same. If you put two devices in same slave address, then whole loop may be whole, that chain will be disturbed sometimes. And then you have to do the wiring of those relays. How you will do wiring? Always positive of one MFM will go to the positive of another MFM, and negative of that MFM will go to the negative of another MFM. I saw always in maximum time that when it will go for one multifunctioning meter to another multifunctioning meter, sometime we reverse those cables in some place, so it will, then your communication will be stopped. You will not get any signal in your RTU, and you will find out everywhere that what happened, and you will say that Smriti didn't told me. No, anyway, so like this you have to connect, and you have to connect to the RTU. So this is the simple method to connect all the multifunctioning meters. So means what else you can do in here, that you have to take those signals like current, voltage, and everything you have to configure in your RTU file. So no need to configure anything in your multifunctioning meter. Multifunctioning meter work is done. You have to just give your slave address. It should be unique. Sometime if it is communicating in RS485 TCP IP, then you have to give a slave address as well as a IP address also. Then the slave address and IP address you have to give, that should be unique, then only it will communicate. If you have TCP IP RS480 means Modbus, then you have to give all those things. If it is serial type Modbus, then only you have to do this type of wiring and you have to do. So lot of methods are there to do the communication of these multifunctioning meters. So the final tip from my side is, if somebody will ask you, is your Modbus is working or not? So generally what you will do, you will have an moxa cable or something. You have to connect to your laptop and you have to check those signals, and it is a very lengthy process. I have a very small easy process to come to check that. That is, take a multimeter, put in positive and negative, put in first you put in millivolt. Okay, first put the multimeter in millivolt, check the voltage between positive and negative. You will get 6 to 7 millivolt always when the communication is up. When the communication is down, you will get 1 to 2 millivolt. This is a type of means, I didn't find why it is like that, but it's working every time for me. So try this one also. This is what my topic completed today. We will meet again in the same time in the same channel with a new video, the part 3 of what is SCADA, and that may be the final part of that this series. So after that series, I will put in-depth knowledge videos like expertise videos, how to configure a RTU, how to add a signal in a RTU, how to add cards in a 560 RTU or 511 or 520 or RTUs. Those topics I will start after that. So please subscribe my channel and hit the bell button, so you can understand more about RTU, and I will tell you about much about ABB RTUs like 560, 511, 520, each and every. So I have lot of top secrets, how the software can be very smooth, and if you are master in Excel, how you can configure a RTU file in 2 minutes very easily. It's very simple. If you know little bit of Excel also, you can configure the RTU file. So please subscribe my channel and hit the bell button, and don't forget to like. Your likes matter. So please like my channel. Thank you very much. Thank you.